is about to start. Thank you so much for having such a wonderful and warm welcome for me. My name is Ramona. I'm here as the boring, hopefully not that boring voice to talk about how to stay secure when it comes to React. So basically, how to probably broke the security of the app, how to get out of it, and maybe learn from one or two things from the history. Because it's not a basically bad sign of a framework. It's always a cat and mouse game when it comes to security. So I'm not really surprised that there might be some things we need to check out. But before I digress, I like to think about security inside of an application like a fortress or a castle, because there's lots of things we want to protect when it comes to our applications, right? So think of your React app as a medieval fortress. And a fortress is sturdy, right? It has defenses. It feels secure. But it's not the only thing, because if you don't take care of your fortress, it will get weaker. So it needs doors, it needs bridges, it needs supply line, and it needs us, we as developers, which are the gatekeepers. And we are really needed when it comes to that, because imagine you are in your fortress, which is your app with all of the things in it to protect. No matter if it's the user data, if it's features you want to maybe monetize with, or the identity of the users itself. If you take a look around you, you often hear about security issues, hacks, leakage, like almost every week. And I guess one of the most well-known ones, and I wonder how many of you had a little more stress in Christmas this year. I see a couple of hands, because there has been a security leak, which is called React Shell. It was basically a remote code execution vulnerability discovered on Christmas. So it was not like a silent night, holy night for us, right? So it basically made it possible to execute arbitrary code on service by sending a single specifically drafted HTML request. And it's actually as scary as it sounds. So yes, no framework is invincible. Not even React. No, most hacks are not basically breaking React itself. They trick us. So what can we do? And to have a wonderful plan in place on how to keep our app secure, it's interesting to learn about our strongest defenses, the foundation of our application, React itself, because it has our back, at least in some extent. So let's take a look what foundations, what wall we have, what React is doing for us to stay secure. And I guess some of you think about one thing which is already helping us, especially in those cases. Oh, I'm a little too fast. So we have JSX in place, which is basically a great first line of defense, taking care of any cross-site scripting by default, which would basically like if a person gets the wonderful idea to input a script as a user input via input field and then it will be executed. This will not happen with React. So JSX is already in place to neutralize cross-site scripting. We will get to cross-site scripting a little deeper later on as well, because it has our bugs, but not in every case. But it is already a wonderful fail-safe. So the browser sees a literal string, not a script, it will not be executed. Two other things which are more like server-side-ish, even though I want to focus on the front end right now, is for example the server-only package to ensure that modules intended for the server will never accidentally get imported into client components. It's pretty handy. Or thinking about Taint API, which are there since React 19 to prevent specific object instances to being passed to the client. So there's already some fail-safes and some parts where React is super good and does even more than other frameworks when it comes to security. However, I mentioned the word packages already, right? If attackers know that our walls and our castles are high, they might go underground. They might poison a well. And in software developer terms, I would like to call this NPM, or basically any dependencies we have. It could happen that people which are not too friendly might target those. And this small form of letters, CVE, is a wonderful database to find out what happened in the past. I already mentioned this small, okay, one moment. Now it unfreezed, wonderful. So there's a CVE number as well, so we already had one of those. CVE stands for Common Vulnerabilities and Exposures, and it's basically a huge database of all with things. And especially on the NPM side, on the supply chain side, we did have lots of issues. And lots of even issues connected more to a human error, like people being hacked, people being basically phished to share their access and stuff like that. There's lots of ways. The most prominent ones are the Axios one. I guess it's not that old, it's from March. Axios was basically a gadget chain attack. If another vulnerability, prototype pollution basically, has happened in any package, and you have Axios in place, this flaw can be used to escalate privileges. So yeah, pretty weird. Or the UiPather.js one, which is a little more older, but it pushed crypto miners to millions of CI pipelines. So always mind your packages, always mind your dependencies, even though it sounds a little more like a drag, but it's really important to do that. Another dependency which could be a problem is all AI-generated code you have, no matter if you basically write it yourself by using an LLM or your agents. So always treat it as a junior. My favorite AI-ish CVE, where I actually forgot to mention the ID, but it doesn't matter, was in WordPress, which is not a small library, I guess. So even in bigger frameworks, it could happen that AI-generated code carries security issues. RDoS is my other wonderful example. What could happen if you rely on AI-generated codes too much, because if the reject is outdated and the regex engine cannot interpret it properly, it might hang on it and then to cause a denial of service issue. So this is basically a regex denial of service attack RDoS. So yeah, last but not least, a wonderful hack which I was able to see is the refract typo squatting attack, which is not only it's not even code related, it's basically having a package in place with a small typo, claiming it, and then hiding malicious code behind it. And some people might use this one instead of the original. So yeah, lots of things to mind when it comes to your supply chain. Supply chain attacks are a thing. And how can we make it better? Basically closing the well, sorry. So even though that sounds a little too simple as possible, but always mind your dependencies, always check them, listen to Dependabot, really. It has its points, and even if it feels like a drag, it's super important to keep everything up to date. Double check your packages, have social media in mind, and if you know that there's a package which has a security issue coming in, maybe don't update right away, but apart from that, still upgrade if you know it's safe. Utilize log files for that, like maybe locking versions in place if you know what you're doing. Vet your AI code, we already talked about this. And if you don't want to do everything of this on your own, use scanners. Maybe even for behavioral ones like Snoop, to keep your eye on everything your code's doing or what it shouldn't be doing. Next one, the warden, the people guiding our castle. Hopefully, don't letting in any weird people we don't want to have inside of our castle or inside of application. So the access control, and hopefully not the broken access control. So a threat could be grabbing the redirect queue. Here in the snippet, which I simplified it a little bit to look a little bit okay on the slide, where we basically have a redirect to from URL and basically feeding it directly to the navigate. And if an attacker knows how you do it, it might send another redirect, another URL into it, and is hijacking to a phishing site. Therefore, there's a couple of ways to do it. So there's a couple of options. I used the whitelist here, so you can see those safe rules variable, the safe route where I know that's okay. But you could do other things like going for a protected root webhook component. In router version 7, there's loaders you could use. So there's a couple of ways to access that. Maybe even going the way of using access control libraries like OpenFGA if you want to have a complete access control layer on to your application. It's hosted by the OpenCNCF, so I guess they are pretty trustworthy. Only trusted packages, right? So I already touched a little bit on JSX because they are protecting us against cross-site scripting, which is basically pretty cool. But I guess it's not completely the full story. So JSX is doing a lot of things already, but I'm not completely sure I would say it is completely the same because there's still some things, especially when it comes to cross-site scripting, which is basically an attack where a malicious script is injected into a trusted website and is being executed as if it was the own. So basically, we invite the attacker in and let him wreak havoc without being noticed. So here, for example, there's the point which I want to highlight a little bit more. The dangerously set in HTML. And I get that it exists because sometimes we need to render raw HTML inside of an application. But we need to be aware that if we do that, JSX is not helping us anymore. The attacker could chime in here. So there's a danger if you use it. And I guess the word dangerously set is pretty telling. So the on error here, which might be an attacker payload, will be executed in this regard. If you do it, try have other like filters or sanitizers in place. No matter if you write them on your own, I wouldn't go for regex-based filters because, as I said, if you do it on an outdated level, for example, you might have a DDoS attack. But for example, DOM Purify is pretty cool, which I have inside of this small snippet. Or other solutions, there's lots of tools. So never write dangerously set HTML without any, and be careful with the custom HTML sanitizers if they have regex. But if you go for DOM Purify, for example, there's still a package, right? You need to make sure it's up to date and take care about it. There's one honorable mention which I wanted to include for our talk as well. It's that one. So basically, click checking. Click checking or UI redressing doesn't even touch our code, but might be a big danger for front-end developers as well because the attacker will trick the user to click something and do actions they are not intending to do. Like a user clicking onto here, onto a fake Win iPhone button, but hits the transfer fund button instead by using an iframe, in which case even basically mimicking our website. And to make sure that this will not happen, that no attacker will redress themselves as our application, you go for the content security policy. It's basically a security standard or an HTTP header or meta tag, which tells the browser what it is allowed to load or execute, like a strict set of rules, so to say. It can look like this, like here it's the most strictest way, which is basically frame ancestors none, nothing is able to be loaded. Or you could go for self instead of none, which will allow some, let's say, allied castles, so trusted sources to be loaded instead. Last but not least, we don't fight alone. That's super important, and you already did the first step because you're here at React Miami and learning, so I'm super happy about you. But you really need to know you're not alone. There's a project helping you, which is the OVAS project, for example. This is a short term for Open Worldwide Application Security Project, and they have lots of resources to help you, starting from meetups, but also like a wonderful, sophisticated online shop where you can have challenges to hack it. And I guess the most well-known one is the top 10 ranking they do. There's one for web, for example, but also for LLMs. There are a couple of those. And we already talked about 3 points of the most important risk, like the broken access control point is the first rank. Injection is 5th, and supply chain issues are 3rd. So yes, they're already reacting to that one. And I found one wonderful thing, which is this one, the OWASP Bulletproof React project. You should check it out because there's lots of resources and lots of more stuff to learn about it, because there's so much more to talk about which I cannot fit into like 20-25 minutes. So check it out if you want to learn more about vulnerabilities, guides, and demos. If you want to build authentication, for example, there's a small shout out for my colleagues at the booth, because we do have a component library for React with some of the components you need to build authentication. It is in early access now, so there will be more. If you want to check it out, visit us at the booth, or if you need some security features for AI or AI agents, you can talk to us as well. So let's wrap up really quick. If there's like 6 things I want you to keep in mind from my talk, aside from cute little drawings, hopefully cute, it is audit the supply chain, make sure you're up to date, validate your routes and your parameters, sanitizing if you use raw HTML, and be aware what JSX can and cannot do. Use content security policy, listen to the OWASP Top 10, and be always careful with your AI code. And yeah, I guess that's about it. My name is Ramona Schwering. Thank you so much for listening. I will be somewhere around here at the booth or in the crowd, so if you have questions, find me anyway. I'd be happy to talk to you. Thank you so much for your time.